So welcome to this latest video on 162 Maths, and in this video we're going over some probability questions taken from some past exam questions on the foundation syllabus. Now, as always, I'll include a copy of the questions that we go through in this video as a link in the description, which I strongly recommend you have an attempt at before watching this video as we go through the answers. Now, before we get started, a little reminder that a copy of the questions is available for you to download and have an attempt at, which I thoroughly recommend you do just to see and test your current knowledge. And again, all you need to do to access those questions, simply click on the link in the description. Now, in terms of probability, not everything and every aspect of the topics included in probability section on the foundation syllabus is going to be tested on this audit. So it's really important that you don't think this is an exclusive. You don't just simply use this audit as a revision for the probability section. You may need to delve a bit further, but also understand that there are many other questions that could be asked in each of the sections. Now, in terms of the questions, I'll put a question breakdown in the description so you can see which question refers to what area of probability. But in this particular audit, we'll cover frequency trees, probability tables, relative frequency, probability scales, frequency tables, Venn diagrams, sample space diagrams, understanding probability trees, and the and or rule. Now, I'll also include a link to my contents page, which includes lessons on all of these particular topics. So if there is anything here that you're not too sure about, I would thoroughly recommend clicking on the link and watching the lesson to prove your understanding. So let's get started on question 1. So question 1 says 500 people are asked if they drink coffee. 9/10 say yes. 20% of the people who say yes at least drink 3 cups per day. And the question 1a says complete the frequency tree diagram. So what we need to do is we need to use this information given to us, and we need to use that to complete the frequency diagram. So we know that the top number is 500. So in terms of yes and no, we know that 9/10 of 500 equals yes. Now, of means time, so we want to do 9/10 times 500. Now, again, if it's non-calculated, you want to divide 500 by 10, multiply it by 9, in which we get the answer of 450. Alternatively, you can just simply type it into your calculator and you would get your answer. Then, if yes is 450, then no is going to be 500 minus 450, which is 50. Then for the yes part, we then need to work out, it then says 20% of the people who said yes. So 20% of 450, well, 10% is 45. So therefore 20% is going to be 90. And then for the no, all I need to do there is 450 minus 90, which gives me an answer of 360. So there is my frequency tree diagram completed. Then for 1b, it says what fraction of 500 drink at least 3 cups of coffee each day? Give your answer in its simplest form. So again, going back to our frequency tree diagram, we can see that the number is going to be 90. So then we need to write that as a fraction, so it's 90 over a total of 500, and then we then need to cancel this fraction down. So if I cancel a 0, that's going to be 9 over 50, and then just double check, can I simplify that? No, I can't, so the final answer is 9 over 50. Moving on to question 2, it says 2 bags A and B contained number counters. Here are 8 counters in bag A, and it says a counter is chosen at random from bag A. Write down the probability that the number on the counter is 4. So looking at this, we can see we've got 8 counters in total, and the number that have got 4 on them is going to be 3. So it's going to be 3 out of 8. Then moving on to question 2b, it says that a counter is chosen at random from bag B. A table gives the probabilities of the numbers of the counters in bag B. Which bag has a greater probability of choosing an even number? You must show your working. So if we go back to bag A, then the probability of selecting an even number is going to be either 2 or 4. So then from this, we've got 1, 2, 3, 4, 5. Oh, don't know what's happened there. 5, so it's going to be 5 out of 8. Then for bag B, if we then work out the probability of selecting an even, Let me just write a little heading here so we know what we're talking about. So an even number is going to be 6 or 8. So that's going to be 0.2 plus 0.4, which is 0.6. Now, as you can see, we've got a mixture of fractions and decimals. So if I then convert 5/8 into a decimal, so here I've got 8 and I've got 5. I know it's going to be a decimal number, so let's add a few zeros. So 8's going to 5 no times. And we've got 5. 8 goes into 50, that's going to be 6 times with a remainder of 2. 8's going to 20 2 times with a remainder of 4. And then 8's going to 40 5 times. So 5/8 as a decimal is 0.625. Now in the question it says which bag has a greater probability of choosing an even number. So out of these two numbers, which one is bigger? Well, it's going to be 0.625, which is bag A. Moving on to question 3a, it says that an arrow on this spinner is equally likely to land on each section. The arrow is spun 72 times. How many times would you expect the arrow to land on a 4? So here this is looking at relative frequencies. So the probability of landing on a 4 is going to be 2 out of 6. And then we need to multiply that by the number of times in which it's spun, which is 72. Now if this is on a calculator paper, you would just simply type that calculation into your calculator and hopefully you would get the correct answer of 24. However, if this is not on a calculator paper, then what I would recommend that you do is simplify the fraction so it becomes 1/3 times 72. And then you want to do 72 divided by 3, which gives us, and let's just quickly work that out, in which we get 7 into 3 goes 2, remainder 1, so we get 24. And then all that's left for us to do is then multiply that answer by the numerator, which is 1, and 24 times 1 gives me 24. Then moving on to 3b, it says an arrow on a different spinner is spun 250 times. Here are some of the results are shown below. The relative frequency of landing on a 4 is the same as the relative frequency of landing on a 5. Work out the relative frequency of landing on a 4. So for this, we know that the spinner is spun 250 times. So if we add these three numbers up, so if I do 25 plus 53 plus 62, I get an answer of 140. Then if I take that number away from 250, I get 110, which basically means that if I then divide that by 2, because it says that it's equally 4 and 5 are going to be the same, and that gives me an answer of 55. So these two numbers here are going to be 55. It then says what is the relative frequency of landing on a 4? Well, landing on a 4, so if I just write rel frequency of a 4, well, that is the number of times it hits a 4, which is 55, over the total number of trials, which is 250. So here we can either write 55 over 250. We can write down a simplified fraction of 11 over 50, or I could write it as a decimal, which is 0.22, and they would also accept it is as a percentage, but I probably wouldn't recommend a percentage, but any of those four answers would get you the full marks. Moving on to question 4, it says here is a fair 6-sided spinner. On one section is red, 2 sections are yellow, and 3 sections are white. 5 probabilities are shown on this probability scale, and it says circle the letter that matches each of the events. So here it says the spinner lands on a red. Well, there is one red, so that's going to be 1 out of 6, and that is represented by B. The spinner lands on a white. Well, that's going to be 3 out of 6, which is a half, and that's going to be C. The spinner does not land on a yellow. Well, the number of non-yellows are 4 out of 6, so then 4 out of 6 is going to be D. And the spinner lands on a purple. There is no purple, so that's going to be 0, which is A. Moving on to 4b, it says the spinner is used in a game. Red scores 5 points, yellow scores 2 points, white scores 1 point. Raj and Ben each have 10 spins. The person with the most points wins the game. Raj scores 22 points. The table shows the results for Ben, who wins the game. So for this particular question, what we need to do is work out the number of points for Ben. So for red, scores 5 points, so we need to multiply this number by 5, in which we get 15. For yellow, we need to multiply that number by 2, so 2 times 1 is 2. And for white, we need to times that number by 1, so 6 times 1 is 6. So if I add up all of those numbers, I get an answer of 23 points. So if Ben has 23 points, Raj has 22 points, who wins the game? Well, that's going to be Ben. Moving on to question 5, it says that a bag has only red, white, blue and yellow counters. A counter is taken from the bag at random. Here are some probabilities. And question 5a says the probability of taking a white counter is twice as likely as the probability of taking a yellow counter. Complete the table. Well, if the white is twice as likely, we don't know what they are, so let's just call this x. And so if the probability of getting a yellow is x, then the probability of getting white is going to be twice as much, so that's going to be 2x. Now we know that in a probability distribution table, which is what this is, we know that all those probabilities must add up to 1 because all the events are exhaustive. So what we've got is we've then got 3x plus, and if I add these two numbers together, get 0.4 equals 1. And again, all I've done is just added up 0.1 plus 2x plus 0.3 plus x. Then if I solve this, I get 3x equals 0.6 and then x equals 0.2. So if x equals 0.2, then the probability of getting a yellow is going to be 0.2 and the probability of getting a white is going to be 0.4. Then for 5b, it says there are 500 counters in a bag. Complete the table. So for this relative frequency, just multiply the probability by the number of trials. So if I go back, the probability of getting a white is 0.4. So that's going to be 0.4 multiplied by 500, which is 200. For blue, that's going to be 0.3 times 500, which is 150. And for yellow, that's going to be 0.2 times 500, which gives me an answer of 100. Then for 5c, it says all of the yellow counters are taken out of the bag. Work out the probability of taking a red counter at random from the bag now. So here, if the yellow counters are taken out, so we're taking out 100, then that means that we've got a total of 400 counters. So then the probability of selecting a red, well, how many reds have we got? Well, we've got 50 over the total, which is now 400. And again, if I simplify that fraction, if I wanted to, I would have got 1/8. But again, if you just wrote 50 over 400, you would have got the 2 marks. Moving on to question 6a, it says in a statistical experiment, in a fair rather, ordinary dice are rolled. Tick a box to show the correct ending to the sentence below. When the statistical experiment is repeated, you will. Now for this one, if you're just rolling a die, then the correct answer is going to be that you're usually going to get a different outcome. So you're going to get, most likely going to get different numbers. It is possible for you to get the same, but you're not always going to get the same. It's not common for you to get the same, and it's not common that you'll always get a different number. It is possible. So the only viable answer is going to be the third one. For 6b, it says tick a box to show the correct ending of the sentence below. An estimate of probability based on a statistical experiment is more reliable with, and the correct answer you want to pick here is the very first one, with more trials. So the more times you do something, the more accurate your statistical calculations are going to be. Moving on to question 7, it says here is a Venn diagram. It shows information about the number of students who have a laptop or a TV. Set L represents the students with a laptop. Now set L is basically just means the circle of L, and set T, which represents the students with a TV, which is basically circle T. There are 50 students altogether. A student is chosen at random. Work out the probability that the student has a laptop. So in terms of the circle of L, if we add up the two numbers in L, that's going to be 6 plus 23, which is 29. And we've got a total of 50 students, so the answer then is going to be 20 over 50. For 7b, it says work out the probability that student has a laptop and a TV. Well, that's going to be the middle number, so that's going to be 23 over 50. For 7c, it says complete the sentence to make it true. The probability that student and then something is 11 over 50. Well, the only time I can see 11 is this. So that is a student who has a TV but does not have a laptop. So that's all we need to write, so that the probability that has a TV but no laptop. Or you could say something along the lines of has a TV only. And again, either of those would be absolutely fine. Moving on to question 8, it says that a number is picked at random from the first 4 prime numbers. A number is picked at random of the first square numbers. The two numbers are then added to get a score, complete the table. So for the first 4 prime numbers, they are going to be 2, 3, 5 and 7. Then for the first 4 square numbers, that's going to be 1, 4, 9 and 16. Again, how have I got those numbers? Well, 1 squared, 2 squared, 3 squared, 4 squared, and then the prime numbers are there as you can see. So if I just fill in the numbers in the headings, then all I need to do is just simply add the numbers up. So here I'm going to have 3, 4, 6 and 8, and then 6, 11. Again, you could do this in any order. I'm just going to complete it as we go. And then 19, and then we've got 9, 14 and 21, and then we've got 11, 16 and 23. Then for 8b, it says what is the probability that the score is a prime number? So prime numbers, well, that's going to be 3, 7, 19, 11, and it's going to be 11 and 23. So here we've got a total of 6 out of 16, and then if we simplify that fraction, we get 3 over 8. But I would say if you left your answer as 6 over 16, then that would be fine. If a question does not ask you to simplify your fraction, then you will get full marks for not simplifying your fraction. Only when it asks you to simplify your answer will you need to simplify when it comes to probability. Moving on to question 9, it says some animals are twice as likely to have male babies as female babies. Explain why the probability of one of these animals having a male baby is 2/3. Now there's a couple of ways in which you could say this. Now an algebraic way would say, well, if you're going to have one male which we call X, then, sorry, a female one we're going to have is X. Just call them X. Then male is going to be 2x, which therefore means the total is going to be 3x. And if we work out the probability of a male, well, that's going to be 2x over a total of 3x. And if we cancel the x's, that becomes 2/3, which is what they wanted me to show. Alternately, what you could say is something along the lines of, for every female baby, there will be 2 male babies. So the probability of a male is going to be 2 over 3, because out of the 3 babies, 2 of them are going to be male. So there we go. Another alternative you could say is that if there are, again, you could use ratios. So male to female is going to be 2:1. So we've got a total of 3 parts. So therefore, probability of a male which has 2 parts to 3 parts is going to be 2/3. So again, any of something along those lines would be absolutely fine. Then for 9b, it says one of these animals is expecting 2 babies. Complete the tree diagram to show all possible outcomes. Well, if the probability of selecting a male is 2/3, then the probability of selecting having a female is going to be 1/3. And then all we need to do is then just repeat this for 2/3, 1/3. So for every time it's a male, it's going to be 2/3. Every time it's a female, it's going to be 1/3. Moving on to 9c, it says the scientist wants to predict the likely outcome of babies' genders. Which is more likely, 2 of the same gender or 1 of each? You must show your working. So if we take each category now, male and male. Now when it comes to probabilities, and means times. So male is 2/3, and means times, and we've got another male. So that's going to be 2/3 times 2/3. Then multiplying fractions, we multiply the top 2 numbers and multiply the 2 bottom numbers. So we're going to get 4 over 9. Then if we do male and female, well, that's going to be 2/3 and means times, and a female is 1/3. So that then becomes 2 over 9. Female and male equals 1/3 times 2/3, which is 2 ninths again. And finally, female and female is 1/3 times 1/3, which is 1/9. Now here, if we're going to work out the probability of it being different, so let me just write that again. So here, if we want to work out the probability that they're different, I need to add the two blue probabilities together. So that's going to be 2 ninths plus 2 ninths, which is 4 ninths. And the probability of them being the same, well, if I add the two, what colour is that? More claret. And that's going to be 4 ninths plus 1 ninth, which is 5 ninths. So which probability is going to be higher? Well, it's going to be the 5 ninths. So it's going to be ones where the genders are the same. And that concludes this probability foundation audit.